Good morning. I've got your energy stories for the third week of October 2021. The first one, the 816 megawatt offshore Empire Wind Project, which is about 14 miles off the coast of New York, filed a request with the Federal Energy Regulatory Commission to delay its start date by about 18 months to the end of 2026, pointing to the permitting process, which is rather lengthy, as well as the complexity of the offshore construction effort itself. Switching from wind to solar, the solar industry is facing some recent headwinds in the form of supply chain challenges and higher commodity prices, emanating especially from challenges around raw polysilicon, which has gone up over 300% in the last 16 months. This is a problem for some developers, as especially the aggressive ones had been counting on solar costs to continue falling. And now they're caught in this bind. So some of them are trying to delay construction, hoping this trend will sort itself out. And while some of the commodity costs have been absorbed by manufacturers of the wafers and panels, some have been passed on, with prices of some frequently deployed types of panels jumping from 21 cents per watt to 24 cents from January to September this year. Switching to the grid edge, renewable energy and solutions provider Swell Energy inked a deal with Redwood Coast Energy Authority to create a community grid program. This will employ as much as 45 megawatt hours of on-site solar-powered storage from commercial industrial customers, yielding additional capacity and resource adequacy in California's Humboldt County. Also on the grid edge, vehicle-to-grid is showing signs of increasing viability. That's the idea that we can connect our vehicle batteries to the grid and offer services at all times of the day. A Thomas-built electric school bus furnished with a Proterra-powered battery system in Beverly, Massachusetts on the North Shore sent power to the grid during 30 separate events this year, totaling 3 megawatt hours, providing that to National Grid, the local utility. While this is one of the first such instances, it's likely to be the first of many in the years to come. Proterra indicates that an average school bus carries students about 6 hours daily, 200 days a year, and they're otherwise idle. So these may be especially useful, perhaps in the summer when solar energy output is really high during midday and the peak is in the evening, so they could store energy in midday and deliver it in the afternoon. The Proterra bus used in this case has a 226 kilowatt hour battery. For perspective, a battery that size could offer about a week's worth of energy to the average U.S. home. So V2G, especially with school buses, probably coming soon to a school district near you. Staying with clean transport but shifting to hydrogen, the Champaign-Urbana Mass Transit District is getting 2 new 60-foot-long hydrogen buses fueled by hydrogen from an electrolyzer that in turn will be powered by 5,500 local solar panels in Illinois. The hydrogen facility is sized to support an additional 10 buses, and the buses and hydrogen power system in this case were funded with $21 million or close to that in state, federal, and local funds. Staying with hydrogen, Volvo Group just rolled out the world's first vehicle made from fossil-free steel. It's a pretty unattractive little load carrier used in mining and quarrying, made from steel produced by Sweden's steelmaker SSAB using green hydrogen from its HYBRIT project in northern Sweden up by the Arctic Circle. The process uses a direct reduction approach that deploys hydrogen in lieu of traditional blast furnace that relies heavily on carbon and coke to eliminate the oxygen from that iron ore. SSAB has announced a goal of expanding its capabilities, producing millions of tons of carbon-free steel by 2026, which Volvo and other automakers have said they'll buy. And switching colors in the hydrogen arena from green to blue, which involves carbon capture and storage, industrial gases producer Air Products announced plans last week to build a $4.5 billion blue hydrogen facility. The project will use natural gas, CH4, and strip out the hydrogen, capturing the carbon that is released when the so-called gray hydrogen is created. The carbon capture makes it blue. This project will be in Louisiana, and the Air Products CEO indicated it will be the largest CO2 storage facility on the planet. Well, those are the stories for this week. Thanks for watching, and we'll see you again next week.